This video is for Experiment 1, Lesson 8. In this experiment, the amount of calcium chloride will be your independent variable, the amount of water will be a controlled variable, as you will keep it constant for all trials, and the energy absorbed or released will be your dependent variable. As you run your experiment, you will use 3 different amounts of calcium chloride for your 3 trials. The amount of water must be held constant throughout your experiment. Choose 3 different quantities of calcium chloride in the range below for 200 grams of water. Okay, so here's our range of calcium chloride. So we need to pick 3 different values here. We have instructions for the actual simulation here. And if I scroll down, I have a huge data table. Now, I think a lot of us see a data table like this and we get kind of stressed out. So I want to go through filling out one entire column for this data table. Okay, so our mass of water is just 200 grams, and I can actually fill that in for all of these. Our mass of calcium chloride needs to be varied between 5 and 25. So I'm just going to pick 5, 15, and 25, okay? You do not have to pick those values, though that's what I'm picking. The next one we have molar mass. The moles of calcium chloride. So I'm going to go over to my .cam and do a simple conversion. So I'm given this information that 1 mole of calcium chloride is equal to 110 grams of calcium chloride. Okay, so this is the conversion factor I'm going to use to solve this out. So I have 5 grams, and that's just that random number that I picked, over 1. Grams of calcium chloride is at the top. So that means that grams of calcium chloride needs to be at the bottom. And that's equal to 1 mole of calcium chloride. Okay, so 5 times 1 divided by 110.98 is just 0.045 moles of calcium chloride. Okay, so as you're going through this, you are going to substitute whatever value you have chosen for grams here, but the rest of this would be the same. So then I can type this in. So 0.045. You want to make sure you have at least 2 non-zero numbers. So I'm not going to round this to the 100th in this situation, because if I did, I would only have 1 non-zero number. Okay. The next box is asking, what is the mass of the solution? So that is the mass of these 2 numbers together. So 200 plus 5 is just 205. You can fill this one in too. 200 plus 15, 215. 200 plus 25, 225. Okay, my initial temperature. So this is where I'm going to have to start actually running my simulation. So I click on experiment and I choose run experiment. And again, those are instructions from the previous page. I'm just kind of following through with that. Okay, so beneath the beaker in the hot plate, select calcium chloride and adjust the mass. Okay, so solids. So this is my beaker right here. And calcium chloride, which you have to scroll down to find it. And then I'm just going to adjust this to 5. Oops. Okay. And then I'm going to click next. My liquid here, I'm going to choose water. And again, this is in the instructions above. And then I'm going to put that at 200. Something you'll notice, 200 grams of water is equal to 200 mils of water. So you should notice that the meniscus is right about at 200 mils. Then click next. And I have my initial temp here at 20 degrees Celsius. Okay, so we see 20 degrees Celsius. So I'm going to go ahead and click, I'm going to show the graph. Click start, and I'm going to scroll down as that's running and type in 20 degrees Celsius. Now you'll notice that the temperature is increasing, and you'll notice that as time is going on, it's starting to flatten out. The nice thing about these simulations, you can run the simulation 10 times with the same numbers and you'll get exactly the same values. There is no variation here. Okay. All right, so 24.27 is our final temperature. So you'll notice that this has stopped moving. This is showing something new, and the replay button is now available as well. Those are all signs that the simulation is finished running. Okay, so 24.27. 24.27. Okay, so next one is change in temperature. This is really important that you are actually following this formula here, okay? So final temperature minus initial temperature, because you might get a negative number, you might get a positive number. Here we get a positive 4.27. Then the next question is asking us to calculate Q. Okay, so just like before, I have my formula. And go back over here. So I have my formula. Oops. Q is just equal to the mass of the solution, which was 205 grams rather, times the specific heat. The specific heat is given to us as 4.18, and then change in temperature, which I'm forgetting that number now. It's 4.27. Okay. So when we multiply this out, we get a rather large number, 3,658.963 joules. Okay. Now I am going to round this number so that it's 3,658.96 joules. Okay, and that's the number I'm going to plug in here. So 3,658.96. Okay, my next question is asking me to fill out what is the change in enthalpy. Now, what this is saying is change in enthalpy is equal to negative Q. So all this means is that whatever number is here, we are going to type that there, and we're going to change the sign. So if your Q value was positive, your delta H value becomes negative. So ours is going to become negative. If your Q value was negative, your delta H is going to become positive, okay? The next one is asking us to convert from joules to kilojoules. Okay, so coming back over here, the conversion between joules and kilojoules is just this, okay? So what I want to do is I'm going to rewrite my joules, so 3,658.96 joules over 1. Since joules is at the top, 1 joule goes down here, 0.001 kilojoules is here, joules cancels out, and we end up with 3.658, 96 kilojoules. And again, I want to round this, so I'm going to round this so that it is 3.66 kilojoules, just so I'm not dealing with that super large number anymore. So I come back over here, 3.66, oops, negative. And then the next one is asking us the enthalpy of the reaction, so kilojoules per mole, okay? So we want to divide the enthalpy in kilojoules by moles. Okay, so my enthalpy in kilojoules, oops, and I forgot to put negatives on all those, is negative 3.66 kilojoules divided by, I had 0.045 moles. Okay, so, and then I end up getting negative 81.33 kilojoules per mole. So now I'm just going to come back and type this in here, negative 81.33, and I'm finished.